In this video, we're going to take a look at how to build molecules with Avogadro. So here I have Avogadro version 1.2, and you can download it from this web page, avogadro.cc. Now, when you first load up Avogadro, you have an empty screen, and that means there's no atom in your system. I'm going to do a first adjustment that I like to do is I change the background color. I'm going to select it to be white. That way when I make a figure, it's convenient for printing, so you don't waste a lot of black ink. So Avogadro has here a menu in which you can interact with the builder in different modes. So currently I'm in draw mode, but there are other modes that we'll take a look in a second. So in draw mode, I can just place atoms on in my 3D systems here, and by default, carbon atom is selected, and every bond that I create is a single bond. I could change that, but let's start with this. So if I just click once, that will create a carbon atom, and Avogadro automatically will adjust the number of hydrogens, so it builds methane for me. If I wanted to just add a single carbon atom, I just have to unclick that option, and here I just get a carbon atom. Now let me delete that carbon atom. I can go here on the select tool, drag the click and drag the mouse over it, and that will select the atom, and then I can press the delete key, and that atom that I added is going to disappear. Now let's try to build one of the molecules that we are assigned to study this week. I'm going to turn on adjust hydrogens. So we're going to try to build a difluoroethylene molecule. I'm going to add another carbon atom here. I'm just going to click, and instead of releasing the mouse button, I'm going to drag the mouse to this other carbon, and that's going to create a bond between the new carbon and the other carbon, and it's going to fill the valence shell with hydrogens. So I've got three new hydrogens here. So I've created ethane, but I actually don't want ethane. I want a double bond here. So I'm going to click again on the bond, and that creates a double bond. So if I want to undo that double bond, I can click with the right button, and as you see, that bond was removed. Now let me recreate the bond. I just go on the first carbon atom, drag again, and there's my single bond. If I click one more time with the left button on the mouse, I get a double bond. And I could get a triple bond if I click once more. Okay, now let's go back to our double bond. Now what I want to do is I want to add the fluorines. But before I do that, I'm going to try to clean up this geometry a little bit. And Avogadro has an extension here under the menu extension, optimize geometry, that will automatically try to optimize the geometry of the atoms. Now Avogadro uses a force field. That means it's an empirical potential surface that it tries to optimize, and the optimal bond length depend on the bonding that you have indicated here in Avogadro. Now this works very well for organic molecule most of the time, but you should be careful if you're going to study transition metal complexes or non-conventional bonding motifs. Okay, let me take now the manipulation tool here, which you can select with the mouse or one of the keyboard keys. And if I click and drag, this will rotate the molecule. Now I can see it quite well. I'm going to go back to the draw tool and select fluorine. Now here there's a limited list of atoms that you can select, but so if you don't find the atom that you want, you can always go at the bottom where it says other, and the periodic table will pop up, and we can select any atom we want, like iron, selenium. In my case, I want fluorine. I'm going to close the periodic table. You can see fluorine is selected here, and I can put the fluorine atoms. Now I want to create a trans difluoroethylene. I'm just going to click on the hydrogen atoms, and that's going to replace the atoms that were there before with fluorine atoms. Now once again, I can optimize the geometry, and you can see now we have the starting geometry for trans difluoroethylene. Now there are a couple of other features of Avogadro that I want to talk to you about. First of all, how do I take this geometry and export it to do a calculation? There are a couple things you can do. You can go to the File menu and save it. I can save it as an XYZ file or various other formats. Or I can go Build menu, select Cartesian Editor, and this will show me a list of the atoms and their Cartesian coordinates. I can change the units that I use to represent, and here I can take this geometry, copy and paste it in a Jupyter notebook. Now this is an interactive window, so if I go here and change something, it will be reflected in the geometry. So I replace one of the fluorine atom with a chlorine atom, and if I click apply, now you can see that this fluorine atom has been replaced by chlorine. Let's go back, reapply that change again. This could be useful if you wanted, for example, if you wanted to specify the position of an atom, or if you wanted to study how two of these molecules interact, you could copy these lines, paste them again, and change, say, the z coordinate. I want to show you another useful feature of Avogadro, is measuring the molecular distance. Now here I'm not measuring the geometry of an optimized structure with psi, so this is not going to be useful for anything. But if you import the output of a psi calculation, then you can use this tool to measure distances, angles, and dihedral angles. So for example, if I select the first atom and the second atom, that will tell me the distance between the fluorine and carbon atom. If I click on a third atom, here I get the two bond distances between atom 1, 2 and atom 2 and 3, but I also get the bond angle. And if I click on a fourth atom, I get the same information plus the dihedral angle between atom 1, 2, 3, and 4. And this dihedral angle is minus 180 degrees. Now, I'm going to leave this tool. I'm going to show you another tool that is very useful. Is this? It's called the bond-centric manipulation tool. This tool is useful if you want to study different conformation of organic molecules. So with the tool selected, I can now click on a bond, and you can see there's a plane that appears right here, indicating that I've selected this bond between these two carbon atoms. Now with the left button, I can grab one of the atoms and drag. And what that does, it rotates in space the group that I've selected around the bond plane that I've indicated before. So now what I can do is I can go from the trans isomer to the cis isomer, and I could create a new geometry, or I can even try to come up with an approximate transition state that connects the two isomers, the cis and trans. So this is a very important tool if you want to study molecules that have different conformers, especially if you have metals or OH groups that can be freely rotated. Avogadro will also generate a psi input, but I do not recommend that you use that right away. If you want to now save this image, there are a couple of things you can do. You can take a snapshot, I think, and you can export the graphics in one of the formats that you have right here. I encourage you to explore Avogadro and look at its features.